Okay, so one of my previous video I have discussed about how we can detect the microsatellite or SSR simple sequence repeat from the RNA-seq or transcriptome data using the tool called MISA. So in that video, I have showed that uh, what are the different programs we need to have in our folder. You can say in your MISA folder for doing this work. Okay, so as we know, this MISA is a Perl-based software, so you should have Perl, active Perl in your folder. Then you should have this Primer 3 software for generating the primers for the microsatellites, means forward and reverse primer with the product length, everything you will get, and you should have obviously the MISA software. So step by steps, how what are the different code we need to use for detecting the microsatellites from the transcriptome we have already discussed in our previous video. So today I'm going to discuss how to do the analysis of the output file. So here ultimately we are getting this file. Okay, so many viewers they have asked this question about this, how we can open this file or how to analyze this file. So today we will understand the file. Okay, and these are the different file how this all have generated using code. For that you can go to our that video. Okay, that is already uploaded in my channel. So let's open this. Okay, so this is a FASTA actually in a FASTA. So you can open it in. I generally prefer this software. So that is called Notepad plus plus. Okay, so you can open it in Excel also, but for easily understanding or easy view purpose, you can use this Notepad plus plus software. Okay, so after opening, as you can see, there are many things you need to see here. Okay, so first, this ID will come. So this is your nothing but the transcriptome context number. We know already what is the meaning of context. After assembling of your reads, you will get context. If you have done de novo assembly, okay. So what is that? It is also discussed in my channel in other videos. You can go through. So now we have context. So under ID, here is the context number. You can see context number 369 like that. It is given. Then SSR number. So this is 111. Then 2, 3. What is the meaning of that? 1 means only one types of your this one is there. SSR is there. Okay. So if you see what is the SSR type means, it is important. So P3 means you have three nucleotide. Here you can say CCT, and this 5 means bracket out of bracket. 5 is there. What is the meaning of that? 5 means CCT. This base is repeated 5 times. So total the base the microsatellite size will be the 15. 3 into 5. So it will be the 15 base pair, 15 nucleotide SSR. Okay, in the quantic number 3. Then this P1 means only single base repeats is there 15 times. C means we know there are different types of microsatellite. C means compound microsatellite. Okay, means there is mixing between these two microsatellite. A80 5 times, then C80 7 times. It is there. Total size is 36. Okay. So then again P1 again you have compound type. P1. So in our case, generally important is P2 or P3, means dinucleotide or trinucleotide repeats. Sometimes we can get also tetra, that is P4. Okay, let's understand the from the first row what are the different components there. So here SSR types P3 means three nucleotide is there, and here five times repeat is there. So total the size of the microsatellite is 15 base pair. So now after getting this file, you have to run this file in Paltree. I have shown you that in our folder Paltree is there, program is there, and Paltree we know is used for designing the primers. Okay, here you can say we have I have showed you that how to design the primer. In this video it is there. Okay, now we got this final output file. Here you can see the types and this one. After this your microsatellite size. Then in that context, from where to which questions we have the forward primer, we can get the forward primer, we can get the reverse primer, it is given. Okay, for if we want to amplify the particular microsatellite, we need forward and reverse primer, it is given there. So forward primer it will be 7252 739, and the base pair it is the forward primer is size is 20 base pair. We know generally we use for PCR 18 to 22 base pair. Here it is absolutely good. 20 base pair, and melting temperature is 60 degree centigrade. Then reverse primer, it is this is the reverse primer. Okay, reverse primer you can able to understand what is the meaning of reverse primer. For PCR we are using the reverse primer, and what is the size of the reverse primer, this much, and the TM for this reverse primer is 59.79, and total product length is your 193 base pair. In this 193 product length, we have our microsatellite of 15 base pair. So if we amplify the DNA, cDNA, using this primer, using p-share, so you will amplify the sequence of 193 base pair which carry our microsatellite 15 base pair repeats. Okay, and so CC repeats five times. So that is the thing. This is the first set of primer. If you again scroll right side, so you will get second your primer set, and your second product size also you will get here. It is given three primer set we are getting for the first quantics. Critic number three. So we know there are different softwares we can use like Gene Runner also for designing the primers, and based on your sequence, it will give you the numbers of your primer sets. So generally, this first one is the best. Okay, and we can see here the TM difference also very less, so it should be less than 5 degree. We know that, and it is nearby, so it is very good. 60 degree, it is high actually. TM, that is also good, and the difference is also very less. So we can say this set of primer is very good for amplifying the microsatellite of 15 base pair CCT repeats five times. Okay, so that is it. Which type of microsatellite? Tri repeats. Okay, and here if you see this example, so this one is two times repeats is there. Okay, SSR die types of. Okay, like what we can see, P2 means only two base repeats is there seven times. So total base pair will be of this microsatellite will be 14, 2 into 7. Okay, and your will start from 2018 to 2031, and the for forward primer sequence is this one. Is melting temperature given, And what is the size of the your primer? 22. Yeah, reverse primer. It's your this temperature. Melting temperature is given, and this one is the your primer size, and total product size is 188. So this way you can easily able to see your or analyze your data. Now, one thing is there. So mainly for us, as I told, P2, P3, they are important. They are generally used for this purpose. Okay. They are generally considered as SSR. P4, P5 sometimes may be there also. Okay. But to understand which means, and here it is showing contact number three. Okay, we don't know which gene is this. For knowing the genes, what do we need to do? We need to blast. We have already this context or sequence with us. We can blast the sequence. From there we'll understand which gene is this. So depending on your target, suppose you are working on growth or disease, okay, where you want to see the genes that is actively participated in the different characters, but depends on your need. Okay, you need to select the genes from this is the whole data. Here you can see numbers of microsatellites are there, so you need to sort it out depending on your needs. So you need to use the blast file to understand which contigs are which genes, and from this file you will understand which type of microsatellites or SS are there in that particular gene. So based on your needs, you have to separate out all the essential or important SSR for your study, and easily you can design. It is already designed all the primers. You can amplify the sequence of the particular genes, and you can say that or you can say you can validate of the all the SSRs using PCR. Okay, and which type of study you are doing, support growth association study or any type of study you can do. Okay, so I hope this file is now clear. Okay, I recommend all of you that you visit our previous video. It is given, it is already uploaded in my channel. Okay, how we can detect the SSR using the MISA tools from the transcriptome data. Okay, so thank you very much.